Step-by-step exam solution. Okay, math class. Training you to excel. Step-by-step exam solution. Subscribe, like, share, alert for the next video. Please drop your comments. It will help me to serve you better. Okay, math class. Present steps to exam success. Step 1, pray. Step 2, plan. Step 3, prepare. Step 4, preview. Step 5, perform. These are 5 steps to success in exam. Okay, math class. Present step-by-step exam solutions to bearings and distances. Number 2. In video 1, we looked at introduction to bearing and backward and forward bearings. In this video 2, we'll be looking at number 1, foundation to solving problems on bearings and distances. Number 2, we'll be studying or we'll be learning bearings and distances problem solving skills. Then number 3, we'll be looking at translating word problems to sketches. And then number 4, we'll look at solving practical problems on bearing and distances. The objective of our presentation now are, number 1, should be able to translate from word to sketches. Number 2, identify and apply the best method to solve problems on bearings and distances. Number 3, solve problems on bearing and distances. So these are the things we'll be studying in this current presentation. Number 1, foundations to solve problems on bearings and distances. Here we have a triangle highlighted, and every triangle is identified by using letters to represent the sides. The capital letter A represents the angles of the triangle. The angle of the triangle there. The capital letter B represents the second angle of the triangle. The capital letter C represents the third angle of the triangle. Now, each angle has a side opposite it. The side opposite the angle A is represented by small letter a. The side opposite the angle B is represented by small letter b, while the side opposite the angle C is represented by small letter c. So now the small letters A, B, and C gives us or represents the sides of the triangle. The capital letters A, B, C represent the angles of the triangle. Now, to solve problems on bearings, because bearings deals with the solution of triangles. To solve problems of triangles using bearings, there are 2 important rules we must not forget. And then we can also apply for simple cases trig ratios, which we have already covered before. Number 1 rule is sine rule. That is used to solve triangles. And what is the statement or the formula for the sine rule? It says the sine of angle A divided by the side opposite it, small a. The angle A divided by the side opposite it, this A, will be equal to the sine of angle B, the angle B, divided by the side opposite it, this angle B. And that will be equal to the sine of angle C divided by the side opposite it, angle C. So that is the sine rule. We can also write it in the opposite to the inversion. Small a over sine A is equal to small b over sine B is equal to small c over sine C, but I prefer this format. Number 2, cosine rule. Cosine rule is also used in solving triangle. What is the cosine rule? For this triangle also, if I'm looking for the side small a, I'll make small a squared the subject. And that will give me small b squared plus small c squared minus 2bc. Then the cos of the angle opposite that first letter. Look at small a in blue. Cos A in blue. So the letter A will not be on the right-hand side of the formula except capital A representing the angle. So therefore, the cosine rule is also very easy to remember, as the sine rule is also very easy to remember. Now, following the same rule, that the one that is the subject will not appear as a small letter on the right side except where you have the angle. Can we now write down the cosine rule to find the side small b? Can you do that? Small b will be equal to, then small b will not appear on the right-hand side, except here we are going to have cos capital B. That will give me a squared plus c squared, because b will not appear, minus 2ac, then cos b. That's where it's going to appear again. What of c? C squared will give us a squared plus b squared minus 2ab cos b, or cos c, sorry. So now that gives us the cosine rule. Now, we come to the condition to use sine rule. To use sine rule, a side and the angle opposite it, that is, if side B is given and angle B is given, then we can use sine rule to find any other, and any other side is given or any other angle is given, we can use sine rule. Also, if I'm given A, and then I can also use sine rule. And then if I'm given C and side opposite it and any other side or angle, I can use sine rule. So that's the condition to use sine rule. Sine rule is used if a side and an angle opposite it are given, and any other side and any other side. Any other side can be any other side, or maybe any other angle, because it's either once the side and angle opposite it are given, then we need another side or angle to apply sine rule. What will be the condition to apply cosine rule? Now, look at this. What do you notice here? The angle B should be given, and the side enclosing that angle. Two sides, A and C, will be given, and the angle between them. An angle is given and the two sides enclosing that angle. That's the condition. Let's look at for the other side too. So you have this side, this angle must be given, and the side that encloses it. These two sides must be given and the angle between them. Then the next condition would be this angle must be given and the side that encloses the angle. These two sides given and angle between them. That's the condition for us to apply cosine rule. To apply cosine rule, we say cosine rule is used if two sides and an angle between them are given. Number two condition to use cosine rule is if all the three sides are given. If all the three sides are given, then it's only cosine rule that can solve that problem. For a right-angled triangle, we can apply Pythagoras rule or simple trigonometric ratios. Can also solve for a right-angled triangle. So now we are going to move to the next slide to solve problem. Now we have a question. The question reads, two ships, M and Q, left a seaport, P, at the same time. Ship M sails to a port X, 80 kilometers from P on a bearing of 280 degrees. That's 3-digit format. Ship Q sails to another port Y, 67 kilometers from P on a bearing of 068 degrees. Calculate A, the distance between the two ships to the nearest kilometer. B, the bearing of ship Q from M. Now, like I said before, problems involving geometry, you must sketch the diagram before you can solve it, or else you will lose everything. So now let's solve this question now. But before we solve, please like the video and share the video with your friends. It's very important. Drop your comments so that we can improve in our service to you. Now we have the north-south direction and then east-west direction. At the intersection, give us the location of the seaport. The seaport P is at that point. Now the two ships, M and Q, left the port at the same time, sailing in different directions. You see, while M is sailing on a bearing from the north, 280, Q is sailing from the north on a bearing of 68. So now we have from the north, 280 is the bearing of M. Also from the north, 68 degree is the bearing of Q. So they are sailing in different directions. Now at the point where we stopped, M and Q are separated by a given distance we are asked to find. Now the question is, how do we get that? So we represent the distance given, and then we represent also the distances given. Now, in any examination, the examiners will want to see the following to give you their 2 marks for the diagram or 1 mark. The first bearing, the second bearing, the distance of Q from P, and the distance of M from P. These 4 important figures must be shown in your sketch for you to earn maximum mark for the sketch. Then we now join the distance from P to from M to Q. So now we are now ready to solve the problem. Now let's solve the problem. We represent this angle to complete the angle of the angle MPQ. How do we get this angle? Very simple. The bearing of M from P is 280. That from the north is 280. If I add this angle phi, it will complete 360. So therefore, the phi can be calculated using point angle property. So phi will give me 360 minus 280, and that will give me 80 degrees. So I've calculated the value of that angle represented by phi. It is 80. So now that it's 80, we need to find angle MPQ. Of course, you should know that MPQ should be the addition of 68 and 80. So MPQ should be equal to 80 plus 68. Add them together. What will be your answer? If you add correctly, you will get 148 degrees. So that's the angle MPQ. Now, we need to find the distance PQ. Now, for this problem, 2 sides are given, MP and PQ are given, and the angle between them we have calculated as 48. Remember the condition to apply cosine rule. Two sides must be given an angle between them. So this fulfills the condition to apply cosine rule. That means I can apply cosine rule to solve this problem. MQ squared should then be equal to this side 80 squared plus the other side 67 squared given. Then minus 2 times the product of those two sides. What are those two sides? 80 and 67. Then you have 2 multiplied by 80 times 67. Then cos 148. Remember, the 148 is the angle opposite the side we are looking for, MQ. So that we have that. So that next is to simplify. Squaring that, we have this. Use calculator, you square this, you get this. Use calculator here, you multiply out. Put the value of cos 148, and that is minus 0.8480. Don't give up. You will make it. So we move to the next slide to continue the solution to the question. So now, this is what we have done before. So now to do that, remember, we are going to apply BODMAS. BODMAS tells us that if you have multiplication and addition and subtraction, which one must you carry out first? Multiplication. So we are going to multiply this. So use your calculator, multiply all this. What are you going to get? You are going to have MQ squared will be equal to this plus this. Then multiply this all out. Minus times minus will be plus. Then you multiply out, you are going to have 9,090.56. Then simplifying further by adding everything together with your calculator, you are going to get 19,979.56. How then do we find MQ? We take the square root of both sides. If I take the square root of MQ squared, I get MQ. Then I'm going to take the square root of 19,979.56. Now, I'll take the square root of that. Please use your calculator now. If you use calculator to evaluate that, you are going to discover that MQ will be equal to, what do you have in your calculator? 141.3 kilometer. That is to 4 significant figure. So therefore, we write that as our answer here. So therefore, that will give me 141 kilometer to 3 significant figure. We drop this because it's less than 5. So that gives us the answer. Then to answer the next question, we import the diagram on the other slide. We bring it forward again so that we can use it to solve the next question. And to do that, we know that the angle NPM is equal to angle AMP is equal to angle AMP. AMP. What's our reason? That's A here. MP. Remember, alternate angles are equal. So that's 2 angles are equal because they are alternate angles. Having done that, then we now write down the sine rule. Sine beta, you can see beta there. Sine beta will be equal to, that's the beta we are looking for. You can see beta here. Sine beta, angle opposite, side opposite it is 67. That will be equal to the sine of the angle we have calculated already that we know, 148, over the side opposite it, which we have calculated. Please, we don't use the approximated answer. We use the answer before the approximation. So therefore, I'm going to have sine 148 over 141.3. The only unknown in this expression is beta, sine beta. So we are going to use that to calculate the value of beta. So what do? Make sine beta the subject. Sine beta will be equal to cross multiplying. You are going to have 67 multiply sine 48. Multiply sine 48. Then divide by 141.3. Then we use our calculator, we replace the value of sine 148, and that gives us 0.5299. Then use the same calculator, we evaluate this. If you have done that, what is the answer you have in your calculator there? It is 0.25126 or 0.2513 if you are going to make it only 4 digits. So that's what you are supposed to have. Then I will write that down. So that is the value of sine beta. So we are going to use that to find the angle beta. So the angle beta will be arc sine. Use your calculator, find the arc sine of this. That's the second function, or the inverse of sine. If you do that very well, you are going to get your answer at 14.6 degrees. So that gives us angle beta at 14.6 degrees. Now we know the value of beta. So the bearing of Q from M, the bearing of Q from M will be the angle from here all the way to this point, this angle. So I will highlight that angle now. Let's call that angle theta. It then means that for me to get the value of theta, this angle from north here to the south here is 180. I know the value of beta. I know the value of 80. So this angle theta will be equal to 180 minus the sum of these two angles. Minus the sum of these two angles, beta and 80. And beta we know is 14.6. Look at the value here, 14.6. Then we'll put it there in place of beta. And then theta will give me 180 minus sum of this will give me 94.6. Use a calculator, subtract. What do you have? You have theta is equal to 85.4 degrees. And that's the final answer to 3 significant figures. Please subscribe, like, share with friends, click for notification so that you'll be alerted when the next video is released. Thank you for watching.